Assalamu alaikum. At the beginning, I would like to thank the conference committee and the organizers to give the chance to participate and present my work at this conference. The study is my research thesis, which is about water demand management in the household sector in Kuwait. And the title of the research is Investigating Water Conservation Strategies in Kuwait, a Multi-Component Backcasting Approach. The talk consists of four main parts. The first part is the introduction, which defines the fundamental question of the research and its aims and objectives. And the second part is the methodology as we adopted the quantitative model construction approach that has three phases. Phase one is the building of the business as usual forecast, demand forecast, as known as the current situation forecast. Phase two is the generation of the macro model, and the last phase is backcasting modeling, setting out the backcast targets, the desired future, and establishing the backcast scenarios. The third part is the output of the model processes, starting with the comparison between forecasting and backcasting scenarios, and then moving on to the wider appraisal of these scenarios in terms of educational and environmental and economic implications. And the last thing is the definition of the measures needed to reach the backcast targets. The last part is the conclusion and recommendations built on the output of the research. The research question is to what extent water conservation initiatives and regulation that targeted the household sector that could transition this sector to more secure and sustainable future. This question has come up with two aims. The first aim is to determine what conservation interventions in the household sector that could transition the sector for more sustainable and secure future. This has three objectives. The first is building the consistent forecast, and the second is generating the macro model, and the third is building the backcasting scenarios. The second aim is the evaluation of identified conservation measures that have been achieved and the appraisal of the wider economic and environmental benefits, its feasibility and public acceptability. This aim has come up with two objectives. The first is the comparison between forecasting and backcasting scenarios and its implications. The second is the engagement of professional stakeholders and policymakers to examine and test the identified measures in terms of feasibility and acceptability. In this study, we have constructed a behavioral model that started with building the conservation forecast, in which the baseline demand estimate from 2013 to 2018 has been generated and validated against the observed demand for the same period. Then the current situation forecast has been built, where sensitivity analysis has been applied, and the central demand projection is selected, after which the backcast microcomponent a water efficiency calculator model has been developed through first building the macro model and its elements, which are ownership, volume, frequency, or which is known as RVF elements. Second is the construction of water efficiency calculator that is then coupled with the macro model, and the last step is the application of this model in a backcast manner to reach the backcasting scenarios. And building the business as usual forecast, which represents the phase one of the model processes, a spatial microsimulation technique has been used. The spatial microsimulation technique is used to combine the aggregate census population with disaggregate sample survey to generate a synthetic population that contains attributes from both populations. In our study, we have generated the household attributes in the aggregate population from the disaggregate water demand survey that comprises first household consumption, second dwelling type, third household sizes, and fourth household status, Kuwaiti and non-Kuwaiti, and fifth is the state's spatial distribution. The spatial microsimulation has been used to generate baseline demand estimate, and then the projected population for the backcast the, for the forecasted period has been used after applying the enhancement procedure to fit the baseline demand estimate population. This procedure comprises bias correction, defining the domestic worker in the population and defining inequality in the household sector. After satisfying the first phase, the second phase of the modeling is the macro model. This model has been developed and fitted in the business as usual demand forecast. The macro component model is applied to forecast water demand in the household sector. It enables for an in-depth investigation where household demand is broken down into components. Each component is then divided in terms of ownership, volume, frequency elements, which gives for better parameter manipulation and defining the transition pathway for the desired future. The micro component of this study is adopted from Water Research Center at Kazan, Kuwait, and further statistical modeling has been applied to fit the research need. This includes a proportional redistribution function and calibration fitting exercise. The phase 3 of the backcasting application. The fitted microcomponent model in the business as usual forecast has been applied in a backcasting manner. The backcasting is unlike forecasting, where the backcasting is precisely looking back from a desired future by setting out targets to the present. This approach has used in the study to transition the water sector to a more secure and sustainable future. The defined backcast targets are first, normal water being surface from the base year, which is 2018. This is equivalent to a reduction of 1% per annum. And the second is an aggressive target, which is a reduction of 2% annually. And the last target is a reduction of 1.5% annually. After defining the targets and manipulation for conservation intervention measures that includes technology, education, economic, and then the backcast scenarios have been developed. The output of the study shows that the baseline estimation has shown a good estimation fit against the observed demand. As you can see, 12 demand forecasts have been developed as a result of a sensitivity analysis, and the central demand forecast has been selected as it's shown in the red dashed trend line. In the central demand forecasting, the demand is mainly driven by Kuwaiti household, as Kuwaiti household consumption is much higher than non-Kuwaitis. Thus, the aggregate demand growth is driven by Kuwaiti households. This figure shows and illustrates the microcomponent water efficiency calculator model and its elements. The table in the left is the components of water used for each household. It shows the volume and frequency elements, whereas the table on the right shows the ownership element of the efficient appliances. And in the middle is the model's manipulation processes. In terms of developed backcast scenarios, 2 packages have been developed for each target. In the first target, which is normal water being surfaced from the base year, which is 2018, the first package is the high market penetration of shower appliances, and the second package is the high market penetration of shower and toilet appliances. The demand in this target has been kept as 2018 demand, which is equivalent to 457 million cubic meter at 2050. The second target is intermediate scenario with a moderate target, which is equivalent to a reduction 1% and half per year. The first package is the high market penetration of half of household components, and the second package is a relatively high market penetration of half of household components, plus the introduction of water pricing, the economic measure for non-Kuwaiti households. The demand has been reduced to reach 345 million cubic meter at the end of the backcasting horizon. And the last target is the aggressive one. The first packages the high efficient appliances adopted with high market penetration for all household components. And the second package is the market penetration of efficient appliances for all household components, plus the application of other measures, which are education and economic measures. The demand in this target has been reduced to reach 239 million cubic meter at the end of the backcasting horizon. In terms of the wider appraisal in business as usual scenario, water production has dramatically increased, and the gap between the production cost and revenue has increased as well. In environmental implication, the carbon emissions has increased dramatically to reach 1,000 million tons in 2050. For the backcasting scenarios and the first target, the production cost and revenue has been kept with no increase or decrease, as well as the carbon, and as the carbon has been kept as it is. And for the second target, demand production has decreased to reach a reduction of 448% in comparison with the forecasting scenario. The gap between the production cost and revenue has been decreased, and the economic efficiency has increased. For the last target, the aggressive one, the production has significantly dropped, and the gap between the cost and revenue reduced, as especially for the second package where the price increase has been applied for all population segments in the household sector. Carbon emissions has decreased to reach a slightly above 400 million tons in 2050. The aim of the study is to inform policymakers and authorities of possible transition pathways as options, to test the feasibility and acceptability of technology options have been introduced in all scenarios pathways, as the economic options are very hard to implement due to legislation and political reasons. Based on backcast options, policymakers can differentiate the more feasible and acceptable scenario. To sum it up, adoption backcasting approach has shown an ability to transition the household sector for more secure and efficient future. Investing in shower component has shown a good demand reduction in the household sector. Applying economic intervention to non-Kuwaiti households has delivered a weak impact on the ground aggregate demand. Recommendations for policymakers and authorities in the state is to shift the focus from water supply implementation policy to efficient water demand management policies. Reform the water tariff scheme to meet the, the Dublin principles, the principles of Dublin statements. Invest in innovative water technology and bringing about the institution capacity building. Thank you for listening.